objective is case statements, subqueries, and joins. With case statements, subqueries, joins, and manipulating string functions. We actually got 4 tonight. So starting out, let's get into case statements. So what are case statements? Case statements are essentially a script that you write that focus on like if then logic. And that logic can be applied in multiple programming languages. Like Python has like the same type of concept. Excel has the same type of concept. It might be like a slight variation, but they all have like if then logic. Case statements also fall under that what is called like the data transformation or conditional logic within SQL. Now, it's also tools for if you are within the analytic space and there are certain conditions that always consistently meet certain criteria, that is when you will use a case statement. For example, within, like, let's say within healthcare, if this blood pressure is met, if this weight is met, if this lab comes back this, then it's called this. Then it's high risk, then it's mid risk, or whatever those categorizations are. That's when a case statement comes into play. When you have a consistent set of data that meet certain conditions and that always fit within those parameters, and they can be categorized based on those conditions, that is where you use your case statement logic. Now, let's get into this logic. And it also kind of goes back to what we talked about last week and the previous week with conditions. Because remember, our conditions will select this from this table where this condition is met. Your case statements fall into that category as well because they have to fit those certain conditions to be called something else. Now, this is the script for a case statement. Here we have our select statement. Select this column, this column. Here we get into our case portion of our code. We're saying case. You got to start out with case all the time. Case when this column is greater than or equal to this value, then A. You provide all of your parameters here. Case when this column. When. Then you get down here and say else. That means if it does not fit any of this criteria, then label it this. Now, you also have to end your case statement. The same way you started it with case, you also have to end it. End as grade. Because the way that your case statement is going to be structured is, it's essentially creating a whole new column in your output. So in this output, it's going to say student name, score, grade. Those are going to be your columns. In your grade column, you'll have A, B, or C. Whereas you're deriving it from the score column. We're pulling it from the score column, but we're going to end it. By the time we end it, it's going to be a grade column. And it's not going to have values like this in here. It's going to have these values in there. Any questions? Okay. So were y'all able to connect to the VM?
Yes.
Okay. Now I am going to, let me look in here and see which one. Okay. So I think that let's focus on the, so let's log into our VM. And for for the portion of this course to focus on these case statements, let's get into this healthcare system database. I think that is a good one. Let's get into this healthcare system database. Now, once you are connected, let me know if you have any questions. I'm going to share my screen. Remember our healthcare system database. This is our server here. My mouse. Hold on, let me find my mouse. There we go. Okay, this is our server here. Remember, our server is the brain. It holds all the databases. Then we get down here to our databases. So let's go into our healthcare system database. Let's expand that. Once you expand that, you see your tables here. Expand those tables and do your data investigation by looking at the columns within those tables. Also, if you want more visibility into the way that the data is actually housed, right-click your table and select your top 1,000 rows. And it will expand your data like this. Now, the first use case is I'm going to leave the case statement up here for you all to use it as a point of reference. But I will give you the logic in the chat. Now, we are in, okay, perfect. We are in the healthcare system database, but I'm not going to tell you the table to use. I'm going to give you the use case, and I need you to do your data investigation to figure out which table answers this question. Once you do your data investigation to figure out which tables answer the question, then you right-click it and you form your syntax to capture the logic based on the data in the table. So y'all ready? So I am writing the logic here. And I'm gonna say it out loud. So when you do your when you look at the video, you have it. Okay. Okay. So if the test result is a severe issue, label the patient extremely high risk. If the test result is abnormal, label the patient high risk. Mild issue, low risk. Normal, no risk. Name that column risk assessment. And while you're doing it, if you want to walk through your code or share your screen or anything like that, you can. So first step, data investigation. What table? What table houses this data? Also, within your output, bring in the test name too. And the patient ID. Yes, very good, Eliana. It is definitely the medical test table. I'm writing it. I'm doing it too, y'all. Make sure also that you document your code. 2 dashes. What is your code doing? This code is categorizing patients based on risk assessment. Mm. Severe cerebral risk. No. Mm. Mm. Normal. Y'all good? Okay. So Eliana said this is what I have so far. So let's see. It says line one is wrong. Okay. So let's see what you got and let's debug your code. So this was my script here. Let me go to yours. Okay. Now, okay. Now, this when you start out your syntax, you don't need your comma before your first column. Think about it like if you are writing a sentence and if you have a series within like your sentence, I want this and this and this, you will put your comma after that first whatever you asking for. So that same applies here. So I'm gonna get rid of that. So, okay. Okay. So I see what you did. Now, this, you got the right idea. But the way that you would have to capture it is you would say case when. Result is actually it's a column. So you wouldn't need to put result in string. Your result will show up like this. So this is the actual one you need. So I'm gonna take it and I'm gonna actually put it right here. I'm gonna get rid of that. Okay. So we got you got your patient ID. Oh, and also remember, anything you put within your select statement, that's what's gonna show up in your output. So you got your patient ID here, that's correct. You got your test name here, that is correct. Or yeah, patient ID test name. Then now you get into your case statement. So let's add us another comma. And now we get into our case statement. That's what you got here. Case when this column. Because remember, we put in our conditions, we put in our logic based on the values in the column. So case when this column equals severe, yep. When result equals severe issue, so you got that right. Then extreme high risk, 100% correct. And you keep applying this same logic for each one of those conditions. Case when this column equals this, then this. When this column equals this, then this. You keep going until you get through all of your logic. So case when this column equals this. So you can really copy that. When result equals abnormal. Then what I say for abnormal? High risk. When result equals mild issue. Yep. Then low risk. When result equals normal, then no risk. Then we got to end it because we got all our category. We said when this column equals this, then this. Now we got to end it right here. End as whatever you want your column name to be. End as risk assessment. From the medical test table. And there you go. Also, make sure that you document your code as well. This logic provides conditions based on results or something like that. Or whatever you're doing. There you go. Remember when we're doing our case statement, we're applying a case to the actual column because we're using it to essentially filter, but that column. So you had the right idea. Also, if it helps you, just which it looks like that's what you did. But select their top 1,000 and then build upon it. But it looks like that's what you did. Yeah, I got any questions?
I was missing the comma before case.
Oh,
to be honest, but
yep. Think about it like how look at our output. We're essentially creating a whole new field or a whole new column in our output. So you would treat that case statement the same way you would a regular, how you would list a regular column. Was your code similar to this one?
yes, and I was working on one risk factor at a time, the same as she was, to make and testing it out.
Yep. Oh, so you were doing it like that? Okay. That's good. If that still works, that's cool.
I got one, I got the other one. So
Exactly. And that's actually how I write my code, like in my day to day. Like I'll start out and I literally start from select the top 1,000. And then I'm like, okay, well, I need to get rid of this. Okay, well, I need to get rid of that. Okay, well, this runs, so let me add this. I layer it. And that's how I teach y'all too, because to me, it's easier when you build your code as opposed to you starting from like a huge picture and then trying to work your way back. Like, no, let's start from like as small as possible. That's how I do it even now to this day. So that's the best way to me. I could be biased, but it's the best way.
No, I think that's helpful because that's how I was making mistakes last week.
How you looked at the bigger picture and tried to go from the bigger picture back.
Yes.
Yep. It'll get you like that when you and then it'll get you, but not only that, it will overwhelm you, especially when you are in a position to try to learn something new. Because it's like, oh my goodness, this is so much. Like tonight, we're gonna get into some joins, and y'all are gonna have to join multiple tables. And it's gonna sound like a lot, and you're gonna have a lot of lines of code. But the best way to approach it is the way that y'all are approaching it now. Piece by piece. Okay, this works. Okay, let me add this line. Okay, let me add this filter. That's exactly how I do it, like to this day. So that's the right way to do it. Ileana, you good? Okay. Yeah, think about those case statements. That's when you get into okay. That's when you get into that data transformation. I had the data looks like this within the output all day long. How do I need the data to look? How is this data useful? Data ain't worth nothing if I can't use it. If stakeholders can't use it, if it's not clean, if it's not clear, they couldn't care less about thousands of millions of rows of data. So that's when you get into the like that data transformation. And y'all probably see that language a lot too. How can I transform this data to make it useful? So next, we get into subqueries. So subqueries falls into that. It falls under the category of like advanced filtering. So when we talk about a subquery, it is essentially a query inside of a query. A lot of times it is not uncommon for people to refer to subqueries as nested queries too. Because what they are is they are essentially a query nested in a query. However you want to look at it, people use them interchangeably. But What that does is it essentially allows for you to retrieve data based on the output of another data of another syntax. Like it allows for you to extract that data, filter that data, but based on the conditions or the comparison of another data, of another syntax or line of code. Now, if you see this subquery, this is a example of a subquery right here. This is a query inside of this query. And computationally, the way that this query runs is it runs the one inside first, and it uses that comparison to compare it against your next query. That's why you got that like advanced logic, advanced filtering. But if you notice, the way that each of these syntaxes is set up is exactly how we've learned how to do them in each of our sessions. This foundation is the same. Like if you see this query right here, what is this part of this code doing? This syntax. Or what do you think it's doing? But I know you know. Just this part.
The average salary?
Yep.
Is that what you're at?
Yep. This part of the syntax selects the average salary from this employee's table. That's all it does. But now you turn around and we want to compare it to another subset of data. Subquery, subset. Now we want to compare it to another subset of data. What is this query doing? These 3 lines of code. What is this doing?
It's retrieving those columns, the ID, the name, and the salary employees table.
What's your condition say?
What the salary is within the subset.
You on the right track. Don't stop.
The average, or given the average of all. Wait, hold on.
Whatever you was thinking about at first, just say it, because I'm almost certain you was on the right track and then you stopped. What was you about to say at first?
Well, so is it given the average or the average of all of the employees? That doesn't make sense. I'm missing something. The average salary of the employees.
Yep. This is getting the average salary.
Right.
This is, like you said, retrieving the employee ID, employee name, salary from the employees table. And what's your condition?
Oh, I'm missing the greater than sign. That's what I missed that whole.
Yes. Yep. That's your condition. Where? This column. Yep. Yep. Where this salary is greater than average. Come through. Come through. This query, we know what this is. This is our aggregate function. We got it formatted right here. Eliana laughing. We got it formatted right here. Because see, one thing about me, I love when like y'all start like, you can look at this code and know what it's trying to do. Or know what it does. 3 weeks ago, you couldn't do that. That's growth, baby. Like, give yourself some flowers. That's exactly what you're doing. Select. This is our aggregate function. We calculate it. Whenever we got our aggregate function, like we talked about last week, select this function from this column, from this table. Give me the average salary. That's it. That's all I want. Give me the average salary. Select, like you said, this is retrieving the employee ID, employee name, salary from the employees table, where this column is greater than this column. Give me the employee ID, employee name, and salary, where the salary is greater than the average. Give me the employees that make above average salary. That's what this is calculating. So this is a subquery. They can, like I said, they can be referred to as subquery or nested query. People use them interchangeably, but they are literally the same thing. Any questions? Okay. So let's go within our customer order DB, or y'all got orders. Let's go within our orders DB, our orders database. This is our server. These are our databases. So let's go within our orders database. Expand your orders database and expand your tables within there. Now, the use case, I'm going to type it in the chat. Okay. So provide me, I need a data extract of all the payments that are above average. I need the payment ID, the payment date, and the amount. Do some data investigation. Which tables answers this? Which tables answer this, and which columns within that table answer this? Data investigation. Second, yeah, that's it. Second, formulate your syntax to capture it. And yeah, y'all see it. And if you want to share your screen or walk through it, we can. And I am doing it with y'all. Let's see the payment ID. Payment date and amount. You know what? Give me the payment method too, y'all. I think that's good information to have. And to give you an easier way, if you select your top 1,000 and just double dash, like comment out which columns you don't need, it'll keep your code easier to read, as opposed to like deleting or pulling through. Okay. Monica, I see your code. I'm about to look at it. Oh God, what I do? Okay, here I go. All right. Yes, ma'am. That's 100% correct. Make sure you did it compile correctly for you, Monica?
I think so.
Did you get a output of the payment amount, payment ID? Did you get all that?
Yes.
Okay, perfect. The only suggestion is to make sure you document what you're doing, what you probably just did on your end and then send it over. But other than that, your code that's 100% correct. You got, let me share my screen. Oh, I am sharing it. So let me pull it over here. Where's my mouse? Y'all, I keep losing my mouse. Okay, here we go. Now, mine is going to be a little different because my database is not set up for the payments. But structurally, you got your select, this payment ID, payment date, amount, payment method from your payments table, where this amount is greater than select average amount from your payments table. This is 100% correct. You feel okay doing it?
I did with the slide, with the, the PowerPoint up, following that.
Ain't nothing wrong with that. Ain't nothing wrong with that. When I tell y'all, I had the cheat sheet that I give y'all, I had a cheat sheet saved on my bookmark up until like 2019. And my bookmarks on my in my browser literally saved on my bookmark from like since until like 2019. I'm just now getting like 3 or 4 years ago where I don't have it no more. Ain't nothing wrong with that. I used to have the cheat sheets that I gave y'all. I used to keep that. I used to have whiteboards in my office with like logic written on them. Ain't nothing wrong with that. That's how ain't nothing wrong with it. So the fact that you were able to do it, that's application. Application gonna be memorization every single time. Because the way memorization ain't gonna hold no value, because tomorrow you might do something slightly different. And it's like, okay, how I'm gonna do it. So the fact that you looked at that, you changed it to fit what you needed, and you applied it. That's grasping the knowledge. So I don't care what you looked at, Monica. I don't care. I don't care. You did it, and it looks good. It's formatted correctly. It looks amazing. So kudos to you. And I ain't lying. I had, huh?
I had a question. Go ahead. What you say?
No, I was just saying I had my bookmarks saved, baby, on my desktop. I had it on my browser. I had it saved as a bookmark. Ain't no shame in my game. The same one that I give y'all. Yeah. What were you gonna ask though?
So on the where statement, we have the nested query.
Yeah.
Where it has from again.
Yeah.
We're pulling from the same table, but is that just the logic of SQL where whenever you have a select statement, you have to tell it again where it's from, like if it's a second select statement?
Yep.
Okay.
And there's 2 froms in here because technically this is 2 different queries. What saves it is these parentheses. You got this query nested in this parentheses. But yep, we pulling because computationally, the way that subqueries work, it calculates this first. Then it takes the output from this and uses it for this. It's going to do the one on the inside first. And whatever that inside one says or does, then it's going to use it for the second one.
Like order of operations.
Yes.
Adults.
Yes. Like that's the order. And whatever your output is here, okay, let's use this as the condition for this one. Because remember, first session, I introduced y'all to conditions where this condition is met. Second session, we said logical operators where this condition is met and that condition is met, or this condition is met between whatever those were still where conditions. This ain't nothing but a condition where this column is greater than this. This is your logic. This ain't nothing but a condition. So it all just like builds upon the next. It looks different. It's more complex, but it's essentially a condition. It ain't no different than where salary equals whatever. We saying where salary is greater than this. Oh, yep. And it helps also when you're able to, like Monica said, when you look at stuff and walk through it, and like how you just did, when you're able to apply it to something else, that always makes it click, because it takes it from being abstract to like, oh, okay, this is what it's doing. Like, yeah, that's exactly what it's doing. Any questions? Okay. So this is our string functions. So y'all know we've talked about string functions, and whenever we talked about strings rather. And I'm like, go make it a string. Go put your two quotes around it. Go make it a string. Go put your two quotes around it. A string is essentially the value that's inside of those columns. It's a string of data. That's it. That is all. Now, what is a string function? A string function is essentially a built-in function that you use to change the way that data is structured. That's when you get into data cleansing. That's when you get into data transformation. That's when you get into providing, as an analyst, that consistency among your data set. What does that look like? For example, if you are in a position and some of your data comes from external, a website, it might be structured differently in a way that you cannot use it. So you got to go in and manipulate it to make it look like whatever you need it to look like. Let's say you are building a dashboard and you have your some data in this column, you needed, and you got some data in this column, and you needed just to build out one column so you can push it out to your dashboard. That's where you use a string function. Let's say you are in a position to where you need to create some sort of ID or some sort of generic ID based on data that already exists. And I'm going to take a few, the numbers from this column and merge them with the last name of this, or however you want to do it. Those are string functions. Anytime you are manipulating the strings of the data to create a new value, those are called string functions. So there are multiple string functions. What we're going to focus on for our session is concat, upper, and lower. And the way that they are essentially formatted, we selecting all day long. Within concat, you say concat, open up your parentheses, your column name, comma. Notice here if I'm doing full name. So I essentially the output would be like first name and last name. So I got first name, I'm pulling data from this column, pulling data from this column, but in between, I essentially put an empty string. When you write your value, and I'm like, make it a string, put your single quotes around it, so you make it a string. Here I put a string. But I made it a space. So it's just going to be an empty string, but it's going to create a space between first name and last name. That's all it's doing. It's essentially a space. As full name from the employees table. I need this column and this column. I have to name it as whatever I want from this employees table. So let's stay within this customer order database since we already here. And could you merge the first name and the last name of customers, please? I just need the first name and last name in one cell of customers. So we're in this customer order DB, but I'm not going to, y'all can figure out. I know y'all know which table. And I put the requirements in the chat, and I'm going to work on it too. And if you want to keep all the additional data there, like the email address, et cetera, you can. And name your column customer name. Also, I think Excel uses concat as well. So it's essentially the same type of concept, which is what I was saying, how once you learn like one thing, it just goes into everything within data.
As soon as you said concat, I got excited. I was like, okay, now I know what you're talking about.
Yep. Because you use Excel a lot, don't you?
I'm a heavy Excel user.
Yes. And isn't when you formulate this within Excel, it's essentially the same thing, concat, and then you put your two cells. Yes, the same thing then. So I know your stuff good. But the same way, I was actually having the conversation on my session on Saturday, and my user from Saturday, she's super heavy in Power BI. And we were talking about how it's important to know about data relationships and stuff, even within Power BI, within Excel, within all those, because you have to merge and stuff based on how that data is related. So it's like the mindset just goes everywhere. Y'all got any questions with that? Or were y'all able to do it? Perfect. Perfect. So those are string functions, and they're essentially used to manipulate, derive insight, clean data. They're used to formulate clean data in a way that's useful. So that is at a high level what string functions are for, and they are used to extract like relevant information. They take the data and they make it useful to whatever you need to use it for. Y'all got any questions about those string functions? Okay. All right. So let's go. This is the start of the show. Okay, this is the start of the show. So let's get into join statements. So whenever you are in a position, It is not uncommon for you to have to take data from multiple tables within your database, or even within other databases sometimes, but we'll talk about that. So it's not uncommon for you to have to join tables within multiple databases. You will have to, let's say you need certain data, but the data exists in this table, but you also need data from that table, and you also need data from this table. That is when you use your join statements. So can y'all see my screen? Where's my mouse at? Y'all, where's my mouse? Okay. Can y'all see my screen? Okay, good. So that's when you get into join statements. So when you get into join statements fall within that data integration and that data analysis, like that relational data analysis. That's when you get into that portion of data analysis. And it's essentially used to combine data from multiple tables. And what that does is it allows for you to perform a super comprehensive analysis. Why? Because you have access to more data. So let's get into the join. So, okay. So there are 4 types of joins. And when I tell y'all that I had that cheat sheet saved on my background, on my browser, I had joins everywhere too, because for some reason my brain for years did not get how joins work. I would be in a technical assessment, and if I had to join something, I would be like, let's go, we can end this right here. And I just woke up one day, like I would apply it over and over and over until one day I woke up and was like, girl, that ain't nothing. So I said all that to say, like, girl, I would be like, what the kids say, I ain't even gonna hold you. That's how I would tell them people, I ain't even gonna hold you. But I said all that to say that the way that I explain it to you all is the way that my brain understands it. And I feel like that there is a gap with how they are presented out here, because to me, it just doesn't make sense the way like everybody else explained it. It just don't make sense to me. But anyway, so let's get into join. So y'all know how I told y'all from session 1, and I was like, there are certain things that are talked about. There are certain things that happen in technical assessments. Firstly, one way you'll do a technical assessment is similar to how we conduct our sessions, which is why I do them like that, first of all. But there are also times to where you might have a technical assessment that consists of somebody just like asking you questions to gauge your knowledge. What is this? What is this? How is this used? How are they used? It is not uncommon for multiple things that are super common that are going to ask. First of all, you're going to be asked about them primary keys and foreign keys, which is why from session 1, I'm like, y'all, this is the primary key. This is the foreign key. This is what this is, because people love that question. Tell me what a primary key is. Tell me what a foreign key is. Another super common question is about joins, because joins will be messing people up out here. But y'all ain't gonna be messed up because I got y'all. So there are 4 types of joins: inner join, left join, right join, and full outer join. Keep this in your arsenal somewhere, because as you start to interview, people love to ask that question. I'm telling you today. Don't say I ain't never told you that, because I'm telling you something right now. They love it. And it essentially is, what's the different types of joins? So let's get into the different types of joins. Inner join. This is your inner join. Your inner join returns common data from both tables. If that data does not exist in both of those tables, it's not going to return it. It's out of there. That inner join has the opportunity for you to potentially lose valid data. Because if that data does not match in both of those tables, it ain't going to return. However, the inner join is common. Inner join and left join, those are super common. But the inner join, look at this, just like this Venn diagram, common data. If it's not common, it ain't coming. I'm rapping. If it's not common, it ain't coming. That's a bar. So yes, that's that inner join. Now, left join. Oh, what you say? Let me see what y'all saying in this chat. Come through bars. yeah. You better know it. You better know it. Left join. Left join brings all the data from the left table and matching data from the right table. If there's no match, it's going to return values, but it'll say no. What is the left table and why do y'all call it that? That's what was throwing me off. The left table has no dependency on the way the tables are structured in the database. None of that. It's not reference to that. When I say left table, I'm saying the table to the left of my join statement. So all the data from the left table gonna come only matching from the right. That is a left join. Right join, total opposite. All my data from the right table, only matching from the left. If it's not a match, it's gonna return the column, but it's just gonna say no in there. Full outer join, give me everything, all the data, all the rows, everything. I don't care if it's a match or not. You will hardly ever use this full outer join. Why? Because let's say I have 2 or more tables, because it is not uncommon for you to join multiple tables. In one of your use cases tonight, y'all actually gonna join like 3 or 4. I don't know. Y'all gonna join a lot, but it's okay. That full outer join brings back all the data from both of those tables, both or more of those tables, regardless of if it is a match or not. So let's get into why those are the least common. They are not as common because if I have a table with 3 million records and if I have a table with 2 million records, that's a lot of data. At some point, it's not good for the database to like run all that. It's called what we call an expensive query. You blocking. You bringing too much data at one point in time. So this is not useful. I mean, you have to know about it, but you're not going to use it that often. What you're going to use is this and this. But you need to know all of them, because if you are asked, what is the difference between each of these? There is an expectation for you to know the difference and to be able to adequately explain what those differences are. And this is the way to do it. Inner join only brings back common data. A left join brings back all the data from the left table and matching data from the right. Right outer join brings back all the data from the right table, matching data from the left. Full outer join brings back all the data, whether there is a match or not. Any questions so far? Okay. So let's get into this syntax. Now, here we have our syntax for our inner join. We are selecting from inner join on. That's the common syntax. That is what we have been doing since day one, selecting from. Now, let's get into what all of this is. So here we are selecting E.name, comma, D.department name from the employees table. This E here is called an alias. What is it? It's no different than in our natural language when we have an alias for something. Her or his name is this, but we call it that. An alias is we're calling the table this. Why do you do that? Because in the event that you are writing your code and your code, I've read stored procedures with 300 lines of code, a lot of code in there. This, it requires you to have a level of readability within your code. First of all, make the code easy to read. Secondly, let's say that you have multiple tables and each of those tables has a column and the column name is the same in 3 tables. So you have to name it and you have to say which table y'all want me to pull this column from. So this is the alias, and you preface your columns within your join. You got to say E dot or whatever you done named your table dot. Me, I name my tables just like this. To me, this makes sense. If my table begins with an E, I name my code E. I name my table E. However, you can name your table whatever you want to name your table. I've seen some people go through their code and they're like A, B, C, D. You know, they go like that. To me, that doesn't make sense because I don't know what it is. But to some people or to you, it might, and it's okay. So you can name your table whatever you want to name your table. Now, here we have our from the employees table. Inner join. This is our inner join syntax. Right there. We have our inner join. Hold on, let me do this real quick. Okay. We have our from this table. Then we say inner join this table. We name this table. Then we come down here and say on E dot department ID equals D dot department ID. What you joining on? What's the common field? That is why I'll be on y'all about doing your data investigation and looking at those data relationships. Why? Because you have to know how your data is related in order to ensure that you have a high level of data quality. But not only that, but you have to go through and be able to say how your data is related in the event that you have to write your join statements. So that's why from session 1, I'm like, what's the relationships, y'all? To coach you and to coach your mindset into looking at your data and automatically deriving out those data relationships because they're everything. And like I said, not only within SQL, but they're everything within Power BI, Excel, whatever you're doing, Tableau, whatever you're doing, those data relationships are critical. So here, select column from this table, inner join this table on these fields. The way that my brain works is, think about it like how you have like a Lego and you stacking these Legos on top of the other one, but you got to stack them because they got to fit. That's what their join is. They have to fit. It has to fit. Any questions? Okay. Now here we have this pseudo table, this employees table. We got our employee ID, our name, and our department ID. Notice within our syntax, we saying select E.name from the employees table. That means give me the name from this employees table. D.department name from the departments table. Give me the department name from this department table. On department ID from this table equals department ID from this table. This is your output here. Now within an inner join, we only bring back common data. So who's missing or what is missing from this result out of these 2 tables and why?
Sales is missing because it's not common on both tables.
Yes, ma'am. Yep. So it's out of there. It's out of there. It's gone. That's exactly why it's missing, because it's not common in both of those tables. Left join. A left join returns all your data from your left table and common data from your right. What is this left table? What is this? It's this table. It's table to the left of your join statement. That's it. That's all. That's what had me thrown off for literal years. Select E.name, the name for my employees table. D.department name, the department name for my department table. Selecting those from the employees table. I have to specify which join I want. Left join this table on these fields. The common field. E.department ID equals D.department ID. Now, this our employees table. This is our departments table. If we are doing a left join on our employees table, which data do I have an expectancy to, which data do I expect to come in my output? Which table do I expect a full table within my output? All the data.
Employees.
Yep. Why?
Because it's that's the table that's to the left of the statement.
Yep. Which data was actually eliminated within our result? And why?
Again, the sales is not from the department's table. It's not on the results table because it's not on the employees table.
Yep. There is no department ID 3 in this employees table. So it gave us Beck because she has the department ID 3 or he, I don't know. It's Beck. I don't know. But it gave us Beck, but it did not give us a department name because we don't have a department ID 4 within our departments table. So it pulled the employees table. It pulled the name because that's coming from the employees table. Like you said, all the data from that employees table. But it gave us null. So the left or right will always it'll bring back the data, but it'll say null in whatever field that does not exist in that other table.
I just want to make sure I understand.
Okay.
So the employees table is the left table,
Mm-hmm.
and we're bringing whatever is common from the departments table to the employees table. Is that correct?
Yep, we are joining our employees table on our departments table. In a left join, it's going to bring all the data from the employees table, whether it's a match or not. It's going to bring all the data from the left table, common data from the right table.
Okay.
All the data from this one, it got to be a match from this one.
Okay.
And then you join it on the field, the common field. When you go in and looking at your data and you like, what's the relationships? This is why. Did that answer your question?
Yes, thank you.
You're welcome. Right join. Select E.name, D.department name. Select the name from the employees table, department name from the departments table. We specify right join on the common field. This is our employees table. This is our departments table. This is our output. Which table does this syntax fully return? Which data does this return? What does it eliminate and why?
pulling all the data from the departments table, because that's the table that's to the right of the join statement, and matching the employee from the employees table.
Yep.
Based off of the common department ID.
Yep. Yes, ma'am. Yes, ma'am. Were you about to ask something?
This may be a simple question. I don't know if I'm overthinking this. But just in general.
You know I don't care nothing about that. Ask your question.
But just in my mind, to make sure I'm making it make sense.
Mm-hmm.
Like, is there really a point in the right join? Because couldn't I just do a left join and then switch department and employees?
Yes. Yes.
Okay.
You're not wrong. You're not crazy. That's not simple. And that's why the inner join and that left join, because naturally, when you think about how we naturally navigate and how we write things, how we're taught to write things in our natural language, in paragraphs and emails, we write left to right. That's how we're taught from like forever. So naturally, when you need all the data from somewhere, you're just gonna say, look, I do at least naturally. I always pull out a left join because like I need all that data. But yeah. Yep. And definitely not a simple question because it makes sense to use it that way. And the fact that so you 2 for 2 for tonight. The fact that you're able to like see it and be like, well, can I do it this way? Absolutely. Absolutely. Which is evidence of application. That's why memorization ain't worth nothing. It's the application. So you 2 for 2 tonight. But you're exactly right. Because naturally, you're going to write left to right. And even if, like you said, if I want all this data, I just flip the tables. But yeah, you're right. Full outer join. All the data from all the tables, regardless of if it's a match or not. We are selecting this column from this table, full outer join this table on the matching field. This is your employees table, this is your departments table, and this is your result. See how it pulls everything? It's going to pull everything. It doesn't even have to have a match. It's going to pull everything. Now, that is also why you won't hardly use this one either. And only due to the fact of, like I said, it's very risky if you have 3 million, 4 million, 5. It's too much data. It's too much data. So your most common ones will be like the inner or left. But for sure, you need to know what they're used for, and you need to be able to speak to it, because that is a common question to like gauge knowledge. Any questions? Let's go then. Okay, I'm about to give y'all a use case that requires for you to join tables. We are actually I'm doing some data investigation myself. Okay. So I'm about to write y'all use case in the chat if I can find my mouse. My mouse. And we are in our let's go back within our healthcare system database. Every time I see you gassing me up in the chat about them bars, I'm gonna laugh, Keisha. Don't gas me up, man.
You deserve it. Come on, man.
Patient first name. Oh, I'm saying it out loud. So hold on. Okay. Okay. Provide me, and this, like I said, we're in the healthcare system database. So give me the patient first name, the patient last name, the date of birth, gender, test name, test date, appointment date. So first thing you need to do, your data investigation. Okay. Okay, perfect. First name, date of birth, gender. Also, remember anything. Thank you. Anything that you expect within your output, you have to put it within your select statement. And I'm writing my code with y'all. So, okay. So test name. Oh, let me go on mute because I'm talking through it too. I'm gonna mute myself, y'all. T dot test name. Test name, test date. T dot test date. T dot test name, test date, an appointment date. Appointment. Where the appointments? Where the appointments date? Okay. Appointment date. Equal P dot patient ID. Appointment date. Okay. A dot appointment date. Holiday. Okay. Y'all have any questions so far?
I have a couple of questions. I'm going to talk through it.
What's up?
Well, from my investigation, it looks like it's going to be 3 tables. Okay.
Yep. Which 3 tables?
Okay. The patient's table, medical test, and the table.
Yep. Yep. Now, what's your next question? How to join all 3 of those together?
Yeah, in a sense, yes.
So, piece by piece, join one table to the next, and then join one table to that table.
Okay.
So you will have you will have 2 you will have 2 left join syntaxes. You will say select all of your columns from the first table. Use I will tell you this. So I want this information regardless of, I want it for all patients.
Okay.
I want it for all patients. So list your table, put your join syntax from where's my mouse at? Okay.
Can you flip it back to the left join?
That's exactly what you need. From that table, left join the second table on your logic. Then you turn around and put another join statement right underneath that. Join this table on this logic.
Oh, okay. It's coming together. I got it.
Yep. So break it down piece by piece. Join one table and then join that table on that table. Monica, y'all good?
Yeah, it's just working through it.
Okay. I want to be on. Oh, it's okay. Go back and look at your video tomorrow after you get some rest. But I know you, and I know you over there overthinking. But go off. I already know you are. I know you are. Chronic overthinker.
So I have a question.
Okay.
So can the tables only be joined by primary key or any column?
It would be either your primary key or your foreign key.
Okay.
Whatever. Hold on, let me make sure. But that is typically. Yeah. Yeah. All them tables joining on the same column look like. At least that's how mine. Yeah. All those tables joining on the same column. But you need all three of them. Did that answer your question?
Yes.
Okay. Okay. Okay, let me see your code then. Okay, so let me put it on my screen. This was mine, but I'm about to go through yours. Okay, select first. Oh, it didn't pull you. You had a left join on the test table. It didn't put your full script, Monica. Put your after your second on patient ID. Oh, that's the first one. After your first on patient ID equals a patient ID, send the rest of it. But this is 100% correct. Just so you know. It just, I think it's only 240 characters or something like that.
It just disconnected me from the VM.
Oh, it did?
Yes.
Oh. No. Give my girl back her access. Hold on, let me turn it back on. Okay. Or we can actually talk through it this way. But anyway, I'm going to turn it back on. Oh, it's still showing running on my end. Let me see. Yeah, it's still showing running on my end. I just restarted them all. Your code will still be up there if you can connect again, Monica. But you, oh, wait, now I done messed up. Hold on. Okay, here we go. Yeah, okay. So, okay, here we go. I see the rest of your code. Okay. This is perfect. This is 100% correct. Select first name, last name. I like the way that you got your structure, you got your code organized, you have your aliases, you have everything clearly defined. Then you turn around and say from this table, left join, which is the appropriate join, on this field, left join on this table, which is also the appropriate join, on this field. This is correct. This is 100% correct. Now, perfect. Now, can you bring me back a so I'm trying to look at your data set. So we got our patient name, patient first name, patient last name, date of birth, appointment date. Oh, okay. So what stood out to me about your output, which is nothing wrong, the code is right. What stood out to me about your output is you see how we have like multiple patients here. So I'm like, why do we have multiple patients here? But I see that they have different appointment dates.
Okay.
Yep. Okay. Your code is right. You did an excellent job. You really did.
Oh, I have to practice. Yeah. Because if you ask me to articulate how I did this, I won't be able to do that just yet.
Yeah, but you did it. But you did it though. But you did it. And when you get within joins, when you get like joins give people a run for their money all the way around. Like when I like mentioned, I'm gonna talk about joins, even to like students that are already in data or people that are already within the field, they be like, so the fact that you did it and this is your introduction, this is like that's amazing. That's amazing. It really is. It really is. Were you able to reconnect back to the VM?
Yes, I was.
Takesha, you good?
I'm getting there. I got the first left join.
Okay.
I think I got a little slow.
Yeah. It's okay. It's okay. Monica, you did amazing.
Thank you. We're learning from the best.
Oh, thank you. Thank you. I know you was over there holding your breath. I don't know. It's like, girl, this is perfect. Perfect. I'm gonna give y'all one more use case. We'll use the same query, but I want you all to apply some conditional logic to this as well. And I got my conditional logic. Logical operators. I'm sorry. I got my logical operators up there for y'all. And also remember, whenever we're applying those logical operators, we're essentially just saying where. Your where is always gonna go after you join all your tables. We're gonna put our where right here. And you put your conditions in there. It goes at the end of your join statement. So let me see. So I need where the test date was in the year of 2024. And I will show the logical operators. Oh, I didn't mean to say where like that because I didn't tell you how to do it. But anyway, where the test date took place in 2024 and the test was an ECG, blood test, or cholesterol. And I'm going to show the logical operators really small up here with, or can I do it like that? No, let me see. I didn't mean that. So I could go back and forth between the joins to show how to, I think, Keisha, were you still working on the join statement?
Got it.
Oh, you got it. Okay, cool. So this one is, I need that same data set, but I only need where the test date took place in the year of 2024. And where they have ECG, blood, or cholesterol, which would be this N, between the N. Remember to put that filter right after all of that, because I'm getting you got all your data. That's gonna give you all your data. Now we're filtering the data where this condition is met and this condition is met. Y'all good?
Getting an error that I'm trying to figure out. Mirror message.
Okay. You want to work through it together, or you want to try it on your own?
I feel like it's something that I should know by now, and so I'm trying to figure it out on my own.
Okay. Hit me up if you want us to look at it.
Okay, before I share it, I'm getting it on when I'm doing the where filters for the date.
Okay.
But only the second, like the ending of the range.
Do you got where test date? That's your column name because that's what you're going to apply the filter to. Where test date between. And do you have did you make your date strings? Each string.
Yes, I see what I did.
What you do?
I used appointment date instead of
test date. Oh, okay.
I know something's.
Oh, okay. But that still shouldn't have threw no error though.
I don't think so either.
So did you put where like this? Hold on, what my screen? Did you put where test date between this day? Did you make the format exactly like it is within the data? Year, month, day, and same format, and make each of those a string.
I see the error of my ways. I forgot the between.
Oh, there you go there. There it is. There it is.
I got excited because I knew that one, but then I moved too fast.
There it is. There it is.
Okay, I got it together now.
Perfect. Did you put in test name in ECG blood? What I say? ECG blood test and collect. Perfect.
Yes, got that one.
Perfect. Any other questions? Any questions? Monica, were you able to do it?
Yes, I can't believe it.
Why? Why you can't believe it?
Because last week I had such a hard time, but this week is going well.
You've been practicing, Monica.
Mm-hmm.
I've been seeing you on LinkedIn.
Mm-hmm. I'm trying.
You've been popping out. I love to see it. That's all it takes. Repetition, guidance, practice, and application. And the fact that y'all feel more comfortable today than what you did 2 weeks ago, than what you did 3 weeks ago, that's evidence of repetition. Remember how I told y'all, I said it's gonna come with the practice. And the fact that y'all are in here, like Takesha just debugged her own code. Y'all are doing joins. Y'all are doing complex. This is not, we're past simple syntax. We're past it. We ain't doing it no more. But the fact that y'all are over here, you like, okay, well, let me see. But you're able to apply it. That's everything. That's the gap. That's the gap. And that comes from exposure, coaching, pulling through it, repetition over and over and over again. Y'all are doing a wonderful job. Takesha, I can tell that I can and Monica, you got on the VM too. I can tell that like y'all are like doing it because it's just gonna come with time. But the fact that like y'all did this tonight, typically this is like one of the most challenging sessions. Besides next week is the most complex one. But joins are not joins are have a reputation for like not being easy. Like I said, I was a whole data analyst and still didn't get it. So, and that's to give you a little context on like what the expectation is, and the fact that like y'all are doing this is mind blowing to me. So please give yourself some grace tonight. But the fact that y'all are not leaving like, whew. And Eliana, I ain't studying you because you probably over there looking like that, but you just you're a chronic overthinker. And I meet with you tomorrow and I'm gonna have to like, I already know how that conversation go. But y'all are doing very good and I'm very proud of y'all. This is the application right here. So that when you are able, when you're in these interviews, when you're in these technical assessments, when you're in a position to have to show your foundational understanding, this is the foundational understanding right here. As a matter of fact, it's past the foundational understanding because y'all are applying it. And the environment that y'all are applying it in, that is the environment that I work in every day. Y'all are doing the work. Very much so. Very much so. And tonight we did case statements, subqueries, joins, and string functions. And y'all did very good. Very good. Do y'all have any questions? Any concerns? Good. Good. Next week we are doing, let me see what we're doing next week. I know for sure CTEs. CTEs, views, window functions. We're doing those next week. CTEs, views, and window functions. So continue to do your coding challenge. I've been seeing y'all on LinkedIn. Continue to do that. Continue to apply all this stuff. Do all of this stuff because y'all are very much so doing what you need to do. Very much so. If you doubted it, don't doubt it no more. Stop. And if y'all need me, y'all know where to find me. So. Good night, y'all.
So you keep the video up for a few minutes.
Yep, I will. And if because I think they shut down at 10 Eastern, which is what you know what? When I was doing it earlier, I think I might have done it to 9, but I thought I changed it back to 10. They shut down at 10 Eastern, but if it shut down, I turn it back on for you.
Okay. I just want to take a few minutes to copy it, screenshot it, so I can just kind of use it to help me.
Okay, that's cool. That's cool. But y'all did very well tonight. These are complex concepts. This ain't no little dog stuff no more. And the fact that 3 weeks ago, this was like, oh, what is this? And y'all in here doing this, baby, kudos. Kudos. So, good night, y'all. Hit me up if you need me. And just continue to do your coding challenge. Continue to practice like y'all doing because the practice was evident.
Thank you.
Good night, y'all.